Hi friends, we have a new framework from Amazon Science for detecting the hallucinations at the atomic level. Okay, so now this can be a RAG system or can be summarization, basically where we have the LLM produced text as well as some form of ground truth. We can check if the LLM has produced any hallucinations at the atomic level. Okay, so for example, here we have an LLM output. This can be response to a query or maybe some summarization. Okay, and then here we have the reference text. So the way it works is it has an extractor and then a checker. So first you for both we use an LLM. So the extractor, it extracts what is known as these triplets, subject, predicate and object, from the given LLM produced text. Okay, for example, here we have the sang I ran so far away was originally performed by the English New Wave brand A Flock of Seagulls in 1993, right? So from this, the extractor has extracted these three triplets. Okay, for example, I ran so far away, released in 1993. So these are the most important factual information slash triplets from the reference text. Now once we extract them, we use another LLM. We check each triplet if it's actually grounded on this reference or not. Okay, now the output will be for each triplet, it is either entailment, which means it is correct or grounded in the reference text, or it's a contradiction, which means it's a hallucination, or sometimes we cannot say it's right or wrong. It can be too generic or maybe half truth or type of thing. We will see an example. In that case, we call it neutral. Okay. So once we have these outputs, it is up to us how we want to aggregate. So let's see an example. Now this is an app. When you download the repo, you can run it as a web app. We are also going to see the SDK. All right. So here is the LLM produced text, and then here is the reference. Now this reference we can extract from the web as well. Okay. If you want to do that, then we have to enable the Serper API key so that it can browse the internet. All right. Now, if you do auto run, these 4 steps are run automatically. So the first step is to extract the triplets. Okay. So based on our output, the LLM output, these are the triplets the LLM GPT-4o mini has extracted. Okay, and then gather the reference. As I mentioned, either we can explicitly provide the reference or it can be through a browser, internet. All right, and then we do the fact checks. So here you will see the results, right? So this one, for example, let's look at this one. The longest river in the world is the Nile River. That's the statement or a triplet from our output text, right? But if you look at our reference text, it says initially it was thought or historically it was thought Nile is the longest river, but later it was found that Amazon is the biggest or the longest river in the world. Nile is the longest only in Africa. Okay, so that's why this has been detected as incorrect. Okay, so you'll see this is a tricky statement. So historically, actually, Nile is thought to be Nile is thought to be the longest river in the world. Okay, and then here we have another triplet which is grounded in the text, so it's detected as Northeast Africa. So as you can see here, if I do, so the fourth one is this localization. So we can localize the text within the reference as well as the output. Okay, so if you look at it, is located in Northeastern Africa, and here also it says it's located in Northeast Africa. So this triplet is a correct one. And then when it comes to numbers, sometimes it's a little tricky. So here we used this approximately for this one. 6853, it's coming from the output, whereas the original text says 6650. So it's not detected as incorrect or hallucination. It's maybe, right? It's unable to decide. Whereas for the in the miles, it probably thought this approximately is applied only to the kilometers, not to the miles. So that's why miles is detected as incorrect, whereas kilometers is detected as it's unable to decide, right? And finally, here we have another ambiguous sort of statement where it says it flows from the sources, this Burundi, Rwanda, and Tanzania. Whereas if you look at in the reference, as we can see here, there are many more places like Uganda, Kenya, Ethiopia, South Sudan, Sudan, Egypt, etc. Right? So that's why it has been flagged as this kind of neutral or maybe. Okay. Now, as I mentioned, once we have these outputs, depending on our use case, if it's a very sensitive one, even if there is one contradiction, we might flag the whole output as contradiction. Whereas if it's not that sensitive application, we might count, hey, out of let's say 6 triplets, 2 of them are correct. So there is 30%, 33% is based on the ground truth. Maybe 2 of them are hallucination. So there is 33% hallucination, so on and so forth. So you can define the rules however you want. Now let's look at the SDK, which is how we are going to use in any application. All right, because it is developed by Amazon Science, they promote their AWS Bedrock models. If you want to use, set your AWS credentials, but you can use any LLM. All right, so from RefCheck, we have the extractor and then the checker. Now we don't need a question. As I said, all we need is LLM produce response and some reference text. Okay, so here we have a response. Let's say this is a RAG system where the user asks this question, and then we are comparing, let's say, 2 different generators. All right, because here the retriever is the same, the reference is the same, right? So the response from model 1 and the response from model 2. So as we discussed, the first thing we need to do is extract the triplets from these responses. Okay, so here we initialize the extractor. The important one is just specifying the model, the batch size, don't worry. I mean, that's when we check many examples. All right, now for the claims format, we have seen the triplet, right? The subject, predicate, and the object. They have another method called this substatement one, but I think this triplet one works better. All right. Yeah, once we have the extractor, just run the extractor simply by providing our response text. Okay, so this is a list so that we can run as many as we want. Now we can limit the number of new tokens or the triplets generated using these tokens. So here is the output. So from the response 1, now these are the 6 or 7, I think 6, 2, 3, 4, 5, 6 triplets have been extracted. From response 2, these have been extracted. Now once we have the triplets, again we need another LLM to do the check. We are using the same LLM. Again, initialize the checker, and so we are just stitching together these triplets. Okay, and then we created this batch reference, and we run it over all the triplets. So for each triplet, this is the response. It can be one of the 3, either contradiction, entailment, or neutral, which is what we have seen in the app as well. All right, it's a super easy to use library with LLMs becoming more prominent, and there are new and new applications. Checking the hallucinations is very important. Thank you very much.